Hi everyone. I thought this would be the easiest and hopefully fastest way to answer the question that I got in class about the homework. So this is the McGraw-Hill online courseware homework looking at elasticities. And the tricky thing is this is looking at how we review calculating elasticities using the midpoint formula. And so real quick, just how we talked about this, remembering that elasticity is percent change in quantity demanded divided by percent change in quantity or in price, and is our measure of responsiveness, right? Responsiveness to a change in price. So price elasticity of demand, we have said consistently, is percent change in quantity demanded divided by percent change in price. The tricky thing was that in the homework, it kind of looks a little bit weird. It's got extra numbers. It's kind of asking you to do a bunch of equations. And this comes from the problem of the midpoint formula. And the idea built into the midpoint formula is that, let's see what I'll do. If we look at, and this is in the textbook, we've talked about it in class, so I'll just review it really quickly. If we look at a downward sloping demand curve and we compare, like the example that I'm going to show you right now, a change in price from $3 and a quantity of 10 to say $1 and a quantity of 30, we get a different elasticity if we go from a price of 1 to a price of 3 and a quantity of 30 to a quantity of 10 than we do if we go the other direction. And that's not great. We want to have a consistent answer whether we go one direction or the other. So the answer is to use the midpoint formula, because then it doesn't matter whether we're going from a high price to a low price or a low price to a high price. We just calculate the percent change by taking the change in, say, quantity demanded, right? Going from 30 to 10. So we would call that 30 minus 10, and then divide it by, rather than the original point, right? Rather than dividing the change by the base, we divide it by the midpoint, so it doesn't matter which direction we're going. And so to get that, we would say, okay, well, what's 30 plus 10 divided by 2? And that's basically the crux of it. It's that midpoint formula. So let me show you what I'm talking about. Okay, I'm going to switch over and show you my screen. So over here, you can see the premise of the problem, right? We're trying to calculate the elasticity of demand, and we've got 2 points, E and F, associated with a price and a quantity, and another price and a quantity. And what we want to do is calculate the price elasticity of demand as we move from one point to another. And again, this is the whole premise. With the midpoint formula, it won't matter if we're going from E to F or F to E. But the tricky part is that what the problem does is it kind of puts the entire equation in one straight line. So you see it as this very, very long mathematical equation. So here we see the change in quantity divided by, find the midpoint, so adding the two quantities and dividing by 2 to get the percent change in quantity. And then we end up with 30 minus 10 is 20, and 30 plus 10 divided by 2, the midpoint between 10 and 20 is going to be also 20, right? Because that's the midpoint between 10 and 30 is 20. And so you end up with 20 divided by 20, or a percent change in quantity demanded of 1% of 1. And when we do it on the price, right, on the denominator, percent change in price, we're going to do the same thing. We're going to say that we want to calculate that percent change in price by finding the change in price, which is just going to be 1 minus 3 or 3 minus 1. And then they put it all in one long equation, but we could think about it this way as being, okay, now we stick the midpoint formula right here, 3 plus 1 divided by 2. And that's the same as saying 1 minus 3 divided by double parentheses 3 plus 1, and close one parentheses divided by 2, close another parentheses. And that would give us that same equation. And again, here we end up with 1 minus 3 will give us negative 2, 3 minus 1 will give us 2, and then we've got our midpoint here is 3 plus 1 divided by 2, or 2. So we get an elasticity of 1, a one-to-one relationship. So that tells us this demand is unit elastic. We're going to see a one-to-one relationship. I hope that clears it up. I'm sorry I couldn't answer that in class. I just couldn't conceptualize what the question was answering. But let me know if you have any other questions. Hopefully this is a great, easy way for me to answer questions for you on the homework and with other things. Have a great day, and I will see you next time.